Hey, how's it going? Morning. Okay. As long as you can see and hear, we're in good shape.
Yeah.
Okay, so everything is clear. The video is clear, and then the voice as well.
Excellent.
So everything will be fine.
Can somebody make me a host, please, so I can share slides as well?
Yeah, sure. Kan, tuh, jadikan David co-host. Yep.
Abidin, me too.
Oh. Hey, David. Our host said that you can share your presentation.
Okay, I might just do a very quick test if that's all right.
Yeah, it's fine.
Okay, that looks promising. That works.
Okay. Is this in your office or?
I'm actually in the office of a colleague of mine at the University of the Sunshine Coast.
Okay.
Away from home at the moment, and I didn't have very good Wi-Fi where I'm staying. So fortunately, she lent me an office to work in today.
But so far, everything is good. The voice and the video as well.
Excellent. Yeah. Now, hopefully, it'll be nice and stable all the way through.
Yeah, sure. We hope so. Bisa kita mulai 5 minutes ya.
Ladies and gentlemen, the event is going to start in 5 minutes.
Pintar bahasa Inggris ya.
We'll have conversations. Please turn on your camera. Our committee will take some photos of us.
Before we are starting the event, we will have a photo sessions. Please turn on your camera. Our committees will take some photos of us.
Mungkin bisa disampaikan di chat juga ya.
Bapak dan Ibu, mohon untuk dinyalakan kameranya karena nanti panitia akan mengambil beberapa foto. Satu kali lagi mungkin ya. One more time. Oke, 1, 2, 3. Oke, thank you very much. Terima kasih banyak Bapak Ibu. Good morning, honorable speakers, distinguished guests, ladies and gentlemen. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Okay, this is me again, Rifka Fahrunisa. I will be the Masters of Ceremony for the second day of the 4th International Conference of Mathematics and Science Education's 2020, Faculty of Mathematics and Natural Science, Universitas Negeri Malang. For today's plenary sessions, we still have 3 more distinguished keynote speakers. First, we have Associate Professor David Gillen from Griffith University, Australia. Good morning, Professor David.
Morning, all.
Second, we have Associate Professor Chun Yan Chang from National Taiwan Normal University, Taiwan. Good morning, Dr. Chun Yan Chang. And finally, we have our third keynote speaker, Associate Professor Bambang Sumintono from University of Malaya, Malaysia. Good morning, Dr. Bambang Sumintono. Okay. For a brief moment, we would like to invite Associate Professor Dr. Suryani to lead our first plenary sessions with Associate Professor David Gillen from Griffith University, Australia. Ladies and gentlemen, Associate Professor Suryani is one of the senior lecturers in chemistry department. She pursued her PhD at
He will deliver his speech in our second day plenary session of our ICoMSE 2020. Good morning, David. How are you?
Good morning. I'm very well, thanks.
First of all, I would like to read a brief introduction about him, as you can see in the presentation. I want to share my my presentation now. Yeah, wait a moment. Okay, can everybody see my screen?
Yes.
Okay.
Right now.
Okay. Sorry. Associate Professor David Gillen is the Deputy Head of School in the School of Education and Professional Studies at Griffith University in Queensland, Australia. This is around Gold Coast, if I'm not mistaken. And he is now currently is the president at the Australasian Science Education Research Association. Yeah. This is a bit about his education. He was graduated from Avondale College for bachelor degree in chemistry, and then the University of Melbourne for his master education, and he finished the PhD degree at Curtin University at 1998. So this is the year I got my PhD too in New South Wales. And then he got the University of Queensland Graduate Certificate in Science. And the last one is Griffith University Graduate Certificate in Higher Education. Well, actually, this is a series of international experience. He has taught science in 3 Australian states, been a teacher educator in Papua New Guinea, Canada, and Australia. So he worked to support teachers' professional learning in South Africa and the Philippines. His research interests are focused on the ways in which science teachers explain Sorry. This is not for me, eh? Okay. Dr. Sheila's research interests are focused on the ways in which science teachers explain concepts to students and on the use of educational technology in science education. This is our topic today. Yeah. He has published books about education research methods and won an Australian Publishing Award for a series of school science textbooks. So this is the list of selected publications, I believe. They are all wonderful. Education Science, Physical Science Teacher Skills in Conceptual Explanation, Journal of Molecular Liquids, Interfacial Tension of a Liquid Air Interface Thermodynamically Process. This is really interesting for me, especially. Research in Science Education, International Journal of Science Education, the Palgrave Handbook of Global Citizenship and Education. This is also a hot topic. Education Science, the Bulletin and Novel is instructional sequence for conceptual change in physics using interactive simulations. Theorizing personalized education. This is also a very hot topic. Anything personalized, connected science as a strategies, and under theories, constructivism, eclecticism, and research and education. Prof. Julian, I cannot wait any longer. So I think today you can have your presentation entitled this, evidence-based approaches to developing students' conceptual understanding in the physical science. Prof. Chilan, the time is yours.
Perfect. Thank you so much, Dr. Siani, for that very thorough introduction. That's fantastic, because a number of the themes and things that I plan to talk about today were introduced there, which is great. So my research interests and some of the publications around the ways in which we use technology in science education to teach science concepts and the ways teachers explain concepts to students. So let me say thank you very much to Dr. Siani for the introduction, to Ms. Rivka for our fantastic MC, and to Dr. Haberdin, who originally invited me to come to ICoMSE 2020 a few months ago, before we knew that that would not be possible. So I was very much looking to come to Malang and be with you at the conference, and I hope that I'll be able to do that in the future. But for this year, for 2020, the year of the plague, it has to be over Zoom. So I'll try and do the best I can to make it still feel like we're in the room together, if I can. Yep. So let me, one point to note, I won't be able to see the chat while I'm speaking because I'm on a laptop and the slides will take up the whole screen, but I can check questions in the chat after the talk, and Dr. Siani also will be helping to moderate the conversation. So I plan to talk for about 40 minutes or so and give us some time to have a conversation at the end is the goal. So we'll see how I go with that. Yeah. Oops. I've got to remember the order. Share first and then make big. There we go. Okay, hopefully that works. So the topic is about evidence-based approaches. I think this is a mixed audience. There are people who are mathematics and science academics who do the mathematics and the science as their main job, but generally in universities they also teach mathematics and science to others, and there are also people who are maths and science researchers. So hopefully this is useful and interesting to both audiences. To the ways in which we teach concepts to students. So I would argue that the learning of science is the learning of scientific concepts in a way. We do a number of other things. When we're teaching science, we're teaching a set of skills about how you manipulate things in the laboratory, for example. And mathematics, we have manipulatives as well. We're teaching a set of skills about thinking, about how to analyze data, a whole variety of other things. We're also teaching concepts, ways of viewing the world, lenses to see the world through. So in physics, the idea of vector and scalar quantities and the ability to see the world in those ways. In chemistry, the notion that everything, including us, is made out of chemicals, and that we can think about the world at that sort of macro level that we experience it at, and then at the micro level of the atom and what's causing that behavior that we experience, and so on. So teaching science is about teaching concepts, I would argue. And I'm really just going to share some of my research that I've done over the last 15 years or so, I think, overall, and some of the current work, and talk a little bit and think a little bit about the future work, including the potential for some of you to take up this work and continue it if that's something that interests you. So let's have a look. So yes, as Dr. Siani said, Griffith University has 5 campuses across an area in southeast Queensland. So 3 in Brisbane, 1 in Logan in between, and 1 in the Gold Coast. I'm mostly based at the Gold Coast campus, as is my colleague, Dr. Peter Grutenbaugh, who some of you will have heard from yesterday conference. So that's the area that I come from and where our university is. So in brief, I'm going to talk about explanations in science teaching. This is something I've been researching for about 15 years because I felt as though with the constructivist approach, we look very much at what students are doing, thinking, acting, how students are behaving. And we took our eyes off what teachers do and how to make good teachers to some extent. So it's really important. One of the things that teachers do is explain a concept to a student to help them understand. So thinking a little bit about explanations, how to do good explanations, how to do effective explanations, but also how to teach teachers to do that. Because as well as research, I do a lot of teacher education. I teach the teachers, and I want to know how to teach them how to explain a concept well. Because I think historically it's just been, well, you go out there and you teach for a while and you learn kind of by practice how to explain well. But surely we can teach something about how to explain well. The second topic is interactive simulations. So that's computer-based laboratory type activities. I did some earlier work on just visualizations. So how do you animate and simulate? So for example, in chemistry, you want to have students understand the ways that two molecules or 2 ions come together, that particular orientations are important and so on. So I can visualize that using my hands, or I can visualize that using some kind of computer-based visualization, which might be more powerful. So we looked at those for a while, but we found that there was no real educational benefit between teachers teaching the way teachers normally teach and teachers teaching with these visualizations. It seemed to be similar. I think the students maybe enjoyed it more, but it didn't seem to lead to more learning. But once we actually looked at interactive simulations specifically, the ability to go into a computer-based laboratory and actually do experiments, we discovered that combining that with particular ways of teaching that I'll talk about toward the end of the talk led to real increases in learning. So this is what I'm talking about with an evidence-based approach. We can show that the kind of teaching that we're talking about does lead to increased student learning. So I'll describe that approach a little bit at that point. So explanations and explaining. As I say, I've been doing this for some time with initially kind of by myself with a study in Australia, and then I moved to Canada and continued the study there. So that study was sitting in the back of classrooms watching teachers explain across a number of different countries in both chemistry and physics, and just seeing similarities and differences in how they explained ideas. More recently, I've collaborated with some colleagues in Chile in South America and some colleagues in Bremen, Germany in Europe around this kind of work. So this is the European group. Christoph Kugelmeier is the main leader, Horst Schecker and Hauke Bartels, and a number of colleagues at Bremen are thinking about how we explain. Now, one of the things with explanation is that in teaching, we tend to say, don't do too much of what I'm doing right now. Teacher, stand up the front, talk at the class, right? We tend to encourage much more active approaches because we understand that students actively construct their own knowledge. They don't just take in what we give them and then memorize it perfectly and then give it back to us on the exam. They tend to work on it, think it through, process it in their mind. So this constructivist approach, what we're doing when we explain to students is not taking the correct, perfect explanation from my head and putting it in their head. We're giving them some experiences, some ideas, some words, some experiments, some simulations to use to construct their own explanation in their own head. So that's the process that's going on. And when we construct an explanation, we give it to the students, but we do that interactively, in context, in a conversation, so we can see whether they understand, whether they're hearing us, whether their eyes light up and they go, aha, now I understand, or whether they go, right, and they don't get it. Then we have a chance to actually improve their understanding by talking with them more, changing the explanation we've created. Now, that's not true everywhere. I have written textbooks as well, as we mentioned, and created a lot of teaching video recently as well. In a textbook or in a video, I don't have that opportunity. I send my best explanation I can make out into the world, and I can't see how students receive it. So that's a different experience to teaching live in a classroom. So thinking about the ways that we create our best possible explanation, and to create the explanation for an audience that you're not talking to directly, what you kind of need is a mental model of that audience. You need to think about, for these particular students, so for my grade 7 and 8, textbooks for Queensland science students, age 12 to 14, I needed to think about, what do they already know? What have they studied in school? What have they remembered of that? But also, what are their experiences? Have they ridden a bicycle? Have they thrown a ball? Have they swum? Have they used electrical appliances? So I'm trying to connect with my mental model of what they know already to give them the best explanation. To create a good explanation, a beginning teacher, which is kind of where my interest has moved to, needs to know the content, needs to know the science or the mathematics, the content that they're teaching. When I interviewed a lot of students, so as part of this study, I interviewed students in focus groups as well, and they said two things about the teachers they remembered most. That is, the teacher knows their stuff, knows the content, knows the science they're teaching me. And the second one is, the teacher knows me as a person, as an individual. So a teacher who actually gets to know the students as people, not just a mass to teach to, and who knows what they're doing, the students will love them and the students will learn from them. So you need that content knowledge, you need some pedagogical knowledge, and you need to think about making the explanation accurate and correct toward the science. So clearly an explanation in science that's scientifically wrong or mathematically wrong is not helping anybody learn anything good. So it needs to be correct, but it also needs to be audience oriented. In other words, you need to be thinking about who is the audience, who is receiving this, and what will make sense for them. The kind of explanation is very related to the context. So my children would ask things like, why is the sky blue? Or why do we get rainbows? And so to my children, I would say, when they were 4 or 5, I would say, the sky is blue because the sunlight comes in and the air filters it in a particular way, and that's what makes the sky blue. To my second year university physics course, I would start talking about Rayleigh scattering and about the absorption spectrum, and about, I would start doing some equations quite quickly and so on. So the kind of explanation, even of the same phenomenon, is different for the different audiences. And so we need to be aware of who our audience is and what they know and can do. So we were looking at, is there such a thing as a single best explanation? So if I have a particular concept, if I want to explain what happens to an electron in a magnetic field when it's moving, is there one best perfect explanation that if we just find that one explanation, we can put it in all the textbooks and all the videos and everybody will understand? Well, you can probably already guess. The answer is no, because it depends on the audience. The best explanation is the best explanation for that audience, not the single best explanation for everybody in the world ever. So thinking about what good explanations look like, what are the features, what are the common features of good explanations? And so, okay, just to, let me see. No, actually, I'm going to skip and then come back to that topic because we're in the flow. So this is the results of that research on good teacher explanations. And we found that there are many ways to be a good teacher. There are many ways to explain well. And yes, there are ways to explain badly as well. But here are some of the ways that are important. Use of analogies. If I'm going to explain electric current flowing in an electric circuit, I'm probably going to use water flowing in a hose as an analogy. And that helps because the students understand water flowing in a hose better than they understand electricity in a wire. But it can also hinder if there are some features of water in a hose that are not the same as electricity in a wire. So being careful to construct analogies that work, that are good, that are clear, and making sure that the students don't carry it beyond the point where the analogy is helpful to the point where it's harmful. So using analogies carefully. Visuals of various kinds. As I say, if I'm explaining a concept, particularly in physics, I've taught chemistry and physics, I've taught a little bit of biology, I've taught a little bit of mathematics because they make us physics teachers teach mathematics as well. I will usually start kind of qualitatively and I'll start talking with my hands like this a lot, like I'm doing now. But very soon I'll move to the whiteboard and start writing up equations or drawing pictures, diagrams, or we'll go to the computer and we'll start doing some kind of 3D interactive complicated diagrams. But visuals are crucial to explanation in the sciences. It just seems to be something that we know. They also seem to be really helpful in explanations in mathematics. I'm old enough that I was teaching mathematics, particularly introductory calculus, around the time we started to get graphing calculators. And when students started to be able to graph functions very quickly and easily and change them very quickly and easily, their understanding developed more quickly than without that visual representation. The process of explaining, obviously, is checking in with the students to make sure that they understand, reading their body language, but also asking them questions explicitly, directing questions to particular students and so on. So checking for attention, making sure they're listening, checking for engagement, making sure that they are actively engaged mentally, not just receiving, and checking for comprehension, checking for understanding, making sure that we ask them to explain back to us, so that we are sure that they really understood rather than just absorbed and misunderstood or connected it to an existing misconception and so on. So those things are features of good explanations. Context sensitivity, which I've talked about a lot. It depends on the purposes of the learning. Are you explaining to your children because they want to know about the world, or are you explaining to somebody who needs to pass a serious high-stakes exam soon? Like the purposes of the explanation obviously are important to the explanation. Bringing in the concept of exam performance, the teachers who were very good were not just saying, here's how you succeed on the exam, this is all about the exam is the point. Because we don't really want that. What we really want is people who understand science and use it to understand the world. And similarly with mathematics, we want these to be world-opening citizenship things, not just passing the exam things. But at the same time, students do need to pass the exam. They want to succeed, their families want them to succeed, they want opportunities and so on. So the really good teachers would explain the concept and at the same time just throw in snippets. This is how I would do this in the exam quickly so that I don't take so much time, so that I have more time for other questions. This is the approach I would use in the exam to make sure the examiner sees that I understand, and so on. So that attention to the exam was one of the features of good explanation. Humour, jokes. relationships, connections with the students, as I mentioned before, knowing the students as people, being able to joke about the things that they are interested in and they're connected in, using science jokes to actually extend the concepts, the scientific concepts. So, sorry, I'm just going backwards a little bit. This notion of explanation and argumentation, I did just want to touch on because there's more literature on argumentation. If you actually search explanation in science education now, you'll find a few things. You'll find some work from David Tregust, who's one of our fantastic colleagues in science education in Australia, who was working on this right back in about 2000, 1999 and 2000. You'll find some work from me. You'll find some work from our colleagues in Chile, Valeria Cabello and Ivan Salinas. You'll find some work, a lot of work from Christoph Kugelmeier and his colleagues. Those German guys are very, very prolific. They publish a lot and their work is really good. So it's worth checking out. But there's not a huge amount around explanation. There is quite a lot around argumentation. Argumentation has had a fair bit of interest in literature recently. But I would say that the two things are different. They're related. Sometimes you need to use an explanation in an argument or vice versa. But in general, argumentation is trying to persuade somebody to share your perspective. So if I want to argue that nuclear energy, for example, isn't a good alternative for Australia and we should use solar and wind instead, I would argue, I would bring evidence, I would have some logic in the chain of argument and so on. Explanation is the attempt to help someone understand the concept. So in the process of arguing about nuclear energy, I might have to explain how nuclear energy works and why it produces nuclear waste that's long-lived and a whole variety of other things. So there are probably scientific explanations that form part of the argument. But I think it's really helpful as academics writing, researching, thinking about these topics to keep the two things separate, at least in our minds. And we can argue, and there are some arguments in literature about whether we should keep them separate for students as well, whether we should be explaining to high school students, for example, the differences between explanation and argument. So, sounds like we've got some very young scholars as well, which is fantastic. So, so Christoph Kugelmeier and his colleagues in Germany are working on particularly how do we teach these skills of explanation, the kind of things that I just listed, the features of good explanation to beginning teachers. And then how do we assess it? Because we kind of know that at university, what we teach is important, but what we assess is what students pay the most attention to. So the assessment is important, and we need to be able to know whether the teachers that we're graduating have these particular skills. But it's quite challenging. So to do my study, I had to go and sit in classrooms for many hours and create video and analyze video and interview students and interview teachers. It took a very large amount of time over a number of years. We can't do that for our students, our teacher education students. If they're in the bachelor's degree, it's 3.5 years. If they're in the master's degree at Griffith, they're only with us for 1.5 years. So we can't do that. So what can we do? There's a number of different kind of tools and approaches that have been used, and I won't go into this in great detail. But these guys have developed a tool where you show a video snippet of a teacher explaining a concept to a student and then ask the student teacher, which of these 4 explanations should come next? What's the next move as a teacher for this explanation in this context, and why? So you're getting the beginning teachers in a number of little scenarios which work off a video to be able to explain their pedagogical thinking, their reasoning, their judgments that they're making as teachers about how best to explain a concept. So I think it's quite interesting work. It's been published very recently, I think last year. Hauke Bartels, who is a doctoral student with Christoph, published some work on this in his International Journal of Science Education. So if you're interested in the issue of explanation, that's really interesting work to check out. So I'm now going to move on because that's roughly about half of the time that I have in mind. So to the other topic. So, sorry, I've already talked about this slide, but this idea of how do we give them practice as well? There's so little time in teacher education courses to allow the student teachers to practice explaining to each other. Sometimes we will do micro-teaching presentations in class and so on, but it's really quite challenging. So again, using some of these video tools and a whole variety of ways of giving them opportunities to practice and then assessing that. And also using peer assessment. This is one of the things that I talk about quite a lot, is that there's lots of evidence in the literature that says that if you have students in your class at whatever level, at primary school, secondary school, university, assess each other's work, first, that tends to be valid assessment, that the students tend to give the same kind of marks that the teacher would give. The students are actually quite good at marking each other. And we might think that they wouldn't be. We might think that they would give the best marks to their friends and the worst marks to their enemy, but they're actually really quite good at giving the marks. And the other issue is that if you're assessing someone else's work, you have to understand the assessment criteria. You have to be thinking about what constitutes a good performance against this assessment task. So peer assessment is really helpful. It's metacognitive. It makes them think about their thinking and learn about their learning. So I really value it as a strategy in teaching. That's a little bit of a side piece, but okay. So interactive simulations. There are a lot of these around. I'll flick forward and back again with the slide. So this is one from PhET. There's the PhET group, PhET, at the University of Colorado, is an international group that has been producing these for a number of years. And they produce very good ones, and they produce a lot of them. And they are free and open to the world. And they are very well designed in terms of different languages. There, you can effectively change the language of the simulation by just putting a file in the same folder as the simulation. So for students without English as a first language, they are a particular good resource that's available. And they're usually quite well designed and thought about. And I'll talk about this one a little bit in a minute. So this is what I'm talking about, the ability to conduct an experiment. This one's a physics experiment. It's about things sliding down an inclined plane. But they have a large number, and they started out in physics, but now they have biology and chemistry and earth science and a whole variety of other things. So they're worth checking out. I mention the PhET ones particularly because they are available freely and accessibly. There are other simulations around, but a lot of them are proprietary, owned by companies, and therefore very expensive. You have to either buy them or subscribe to their service and so on. So they're less accessible than the PhET materials. But we're always looking for other sources as well of good online simulations. So an online simulation is similar to a laboratory in some sense and different in other senses. There are things that the virtual laboratory can do that the real laboratory can't, but also vice versa. The real laboratory can do things. So for example, in chemistry, I want to have my students develop those skills. I want them to be able to titrate. I want them to be able to decant. I want them to be able to filter. I want them to be able to do all of those things. And virtual laboratory on the computer doesn't teach them those skills because there's a weight, there's a mass to the real apparatus. In physics, the same. I want them to feel what the mass of the pendulum is like when it's swinging. I want them to understand it in some embodied way. So it can't do everything. But at the same time, one of the things that the online laboratory will do is it will usually give you the right answer. And any of us who've taught science know that sometimes the real laboratory won't give us the right answer for various reasons of contamination or various other issues, or students doing weird procedures, or, so it's reliable in that sense. It also tends to allow you to do experiments much more quickly. So on that, on this simulation, I'll move forward to it. I can slide in this case, filing cabinet down the thing, change some parameter, slide it down again immediately. Whereas certainly in the olden days, I would have had to have a little cart on a slope, have a ticker tape behind it and a ticker timer measuring the time, and then make a graph and then physically cut out the graph. And so people who are physics people are understanding that one, and not everybody else is not, but that's okay. Even these days, I probably have some kind of light gate measuring speeds and time and so on, but it's slow. To conduct multiple experiments takes a long time, whereas on this, multiple experiments can be done in a short time. So I think there's really kind of some value in being able to have the students do something, test it, have a hypothesis and test their hypothesis in the moment in the online simulation. So I think that's kind of an affordance. And there's the visual element, which is that I can physically see how fast the thing slides, but there's also a numerical element. So I can type in the applied force in the thing, or I can set it on a slider. I can graph the data. I can get data out. So I can have the students actually analyze the data in a variety of different ways. On this particular one, I can get a work graph or an energy graph versus time. And there are a number of other things that I can do. So there's a number of affordances, if you like, abilities of these online laboratories that are helpful in developing concepts. And that's what we're doing. I said right at the start that learning science is learning concepts. Yes, it's also learning skills, but in the laboratory, whether it's the physical real laboratory or the online laboratory, I want the students to understand what they're doing and understand what the result means. So if I say to the student, why did you do that? Why did you add that liquid to that test tube? And they say, because I finished step 4 and that was step 5, then I don't feel as though they're really understanding what's going on. They're just following a recipe, right? If they say, because this is an indicator and I'm going to use an acid and a base and I need to know whether it's been neutralized or not, so I'm going to put this phenolphthalein indicator into the solution and then I'm going to titrate it, then they understand. And when the solution changes color from clear to pink or vice versa, they understand what it means. Do you see what I'm saying? That the laboratory should be the place in which they're actually testing their own concepts. They are challenging themselves to understand what's going on and using the science concepts as a way of viewing the world, essentially. So I guess while I'm talking about the good bits of online labs, I can also talk about the bad bits. So to me, there are some problems with this particular simulation. One, I think, is this little man standing here doesn't really serve any purpose. When the filing cabinet slides down, it runs into him. So there is a phone ringing in the background here. Sorry, hopefully it will stop shortly. So it doesn't really serve any purpose. It might entertain the students, but it's not giving any scientific purpose. Similarly, the brick walls seem odd to be on top of a pile of books, a big thick brick wall on top of a pile of books. And arguably the pile of books itself is a problem. What's the scale here? Is it brick wall size? Is it pile of book size? This is a very, very, very large ruler if it's that size compared to pile of books, and that size compared to man, and so on. So there are some issues that can confuse some students. And what you probably want in your design of an online simulation is something that includes what's important without all of this other extraneous detail that can be distracting for students. Some of what Kugelmeyer and other colleagues have discovered about explanation as well is that teachers sometimes try to make it easier by including a whole lot of other stories and changing to different explanations and so on, but they actually make it harder because the students need the one simple, single, clear explanation, and adding a lot of extra detail can make it more complicated, not less complicated for them. So I think this simulation could be designed better in terms of those kind of features, that there are, I don't know whether it's in the screenshot that I've got, but you can change the filing cabinet into a piano or into a dog. And again, maybe amusing for the students, but I don't know that it helps with the understanding of the science. So this is an approach that a colleague of mine, Xin Fan, she was a doctoral student of mine from China when I was at the University of Queensland a few years ago. And Xin and I worked together around a teaching approach around interactive simulations. So we developed this approach together, and then she returned to Beijing, China, to conduct the experiment. So she worked with 2 teachers, and each of the 2 teachers taught 2 classes, 1 experimental class and 1 control class. So the control class, the teacher just taught, these were experienced physics teachers in this case. The control class, the teacher just taught the way they always teach that concept. They've been teaching those concepts around force for many years. They know how to do it. They know how to do it well, which shows good teachers. So they just taught them that way. And in the other one, they used this particular teaching sequence that we designed with the interactive simulations. And then we tested the students on, do they know the science? What's their conceptual understanding of the science? Do they have a correct and accurate and quite strong and well elaborated understanding of these concepts around force? Second one was, are they confident they know? So if you say, is the answer A, B, C, or D, and they say the answer is definitely C, I'm confident, I'm sure, or they say, oh, it might be A or it might be C, I'm not so sure. Like, that's a different state of their mind. So we wanted to know, how confident are they that they know? How has what we've done helped them to develop confidence in their own understanding of the concepts? So that because, you know, I imagine that the more confident they are about their understanding, the more it's likely to stick over multiple years, the more it's likely to be used to understand the world throughout the rest of their life rather than just until the end of this course. And finally, we were doing inquiry learning. The students were creating questions, leading the questions, finding solutions to the questions. So there are particular skills around inquiry learning. I think sometimes inquiry is conducted in such a way that we just say to the students, go forth, be free, inquire. And we don't scaffold them up carefully into the skills that are required of thinking, collating evidence, analysing evidence, coming to conclusions, testing conclusions. So we tested to see how well they develop those skills of inquiry learning. So we discovered, I could sort of report a whole bunch of results, but the big headline result is that there was a ICoMSE, an effect size of 1.57. Now, not everybody will necessarily be across effect sizes, I don't think. Very briefly, the results were all statistically significant, but statistical significance, you could argue, is not enough of a test. What we want to know is, how much difference does it make? Does it improve the learning of the experimental group a little bit or a lot? So 1.57 as an effect size means that the mean of the experimental group, the mean score of the experimental group, was 1.57 standard deviations away from the mean of the control group. So people who are very comfortable with statistics will understand what that means, and that is quite a large effect, that the abilities, the scores, the results for the experimental group were significantly bigger than those for the control group. So this was an effective teaching sequence. Now, it was with 4 classes in Beijing. I would love to conduct it in Australia. I would love to conduct it in Indonesia. I would love to conduct it with a much bigger group. I would love to go to chemistry and maybe other sciences as well. So I think there's a lot of scope to do more work. This is exciting finding, to me at least, but it's preliminary. So here's the sequence that we developed. there are 5 steps, sorry, but the 0th step, the first step, the step before the step is decide whether you want to use a simulation or whether you want to use a laboratory, a real lab. And I talked a bit about why you might want to choose each a moment ago. So don't just decide that the simulation is the be all and end all and do everything with simulations. Decide, make a conscious professional decision about how you're going to do it. First one, and I should say actually, if people are familiar with the 5 E's model of science education or a number of other models of stepwise models of science education, this has some features in common with those. So the first step,
excuse me, David, excuse me. I think I want to remind you that your time is also running.
Almost up. Yeah, all right.
Okay. You will have 5 minutes more.
Perfect. That works really well. Thank you.
Sorry.
No worries at all. No, excellent reminder. I was checking the clock as well. So eliciting and clarifying the existing concepts in the class. So finding out what they think already. Some of them probably do have a correct scientific understanding. Some of them have a range of misconceptions. And particularly in chemistry, we understand the common student misconceptions, and in physics to some extent. So finding out what the students think already, then what do they, for the experiment that we're about to do, what does your belief predict? So if you have a scientific conception, what does it predict is going to happen? What's the color change going to be in the chemistry? What's the motion going to be in the physics? What's the reading on the ammeter going to be in the physics, and so on? So what does yours predict? And usually those will be contradictory. It will predict either this or that. And so when the experiment happens, they know what the finding means. So the third step, test the prediction. Go do the experiment. Find out whether your prediction, based on your belief, is supported by the evidence or challenged by the evidence. As I said, the interactive simulation allows you to do multiple experiments, to do multiple tests, and be really sure and confident of how it works. Basically, at this stage, you can say, hey, look, your misconception didn't predict it correctly. Your misconception didn't predict it correctly. What predicted it correctly? The scientific conception. That's why it's the scientific conception. So at this stage, you're actually just clarifying, saying only the scientific conception has correctly predicted what's going to happen in this experiment. It may not happen just in one experiment. You might need a couple of experiments to really test it and make it work. But basically what you're demonstrating is that the scientific conception is powerful. In that conceptual change knowledge, it's intelligible, plausible, and fruitful. It helps them understand the world better and predict things in the world better. And finally, the kind of extension step, testing, developing. Now that you have this concept, what else does it allow you to do in the world? What other experiments will it open up, and so on? So I think a simple sequence, but a powerful one, as I say, because we discovered that it works effectively. All right, and at that point, I will stop and shush, and let's have some conversation.
Okay, thank you. This is all hot topics for us chemistry people. Yeah. We have also already some questions, but for anyone who want to ask directly, I should give the time to you. Please, if someone wants to ask directly, please unmute your speaker and say something. I got one name, Atika, maybe?
Can you hear my voice?
Yes.
Sure.
Okay. Good morning, Mr. David.
Good morning.
I'm Atika from Department of Chemistry, Universitas Negeri Malang. In your first talk, you mentioned that in doing your research, you sat in a classroom to observe teacher teaching, right?
Yeah.
But that's often difficult in Indonesia because many teachers fail often. What approach you applied to persuade teacher to happily involve in your research? Thank you.
Yeah, no, and I think that is challenging. If teachers don't feel confident themselves, then it is quite scary. And even for me, I've been doing this for a very long time. But if someone comes and stands at the back of the classroom, or sits at the back of the classroom, I'm that little extra bit nervous. So yeah, I think one of the things with that study that helped, though, was that we tried to choose teachers who we knew were good. So we went to schools that were receiving good results, and then we asked colleagues to say, can you please nominate the teachers that you think are really good? So then we were able to go to the teacher and say, we hear that you're a great teacher, please may we see what you're doing.
Yeah. Anyone else? Okay, people are shy here. Okay. We have also 3 questions written in the chat room, but actually I have also one question. Yeah. Can I go first? Yeah. Okay, David. For the young generation, it is hard to engage. Yeah, to engage to ask students to learn chemistry in traditional way. So it is difficult to ask students to do reading for 3 pages, for example, to understand one concept of chemistry. Well, on the other hand, we cannot show we cannot use the experimental chemistry right away, and students now we will ask Google first. The things. So the conceptual understanding is built bit by bit more in this time. So they got something in Google, some from Wiki, some from textbooks, but they don't want to learn.
Yeah.
Yeah.
Yeah. I think there's a few things there. One is engaging students in learning chemistry. To me, a big part of it is connecting it with their life experience, so that it's something that they understand actually has implications. And obviously, the higher we get up in teaching chemistry, the more detail we get at atomic level, and it's harder to make that direct connection. But so, for example, in primary chemistry, I will almost always do things in jam jars with household materials as much as possible, rather than fancy laboratory glassware. I want to connect it to students' life experience. It's not because but around kind of readings and so on, I think probably the key is, one thing is potentially using some video rather than some text readings, and I know that's not always possible. Another is really teaching them to judge the quality of what they find online, because they will find a lot of good things on Wiki and Google, but they will find a lot of nonsense as well. So a real important piece of teaching for all of us in all subjects now, I think, is that critical reasoning, that critical judgment, the ability to say, what's the source? How do I know that this is good information, etc.? So that's going to be a crucial part. And I think the fact that students can go out and explore this vast knowledge in the world is great, but they need some skills to do that as well.
Yeah. Because chemistry is hard. Everybody avoid chemistry, and also I think students now prefer to learn something easier than science.
Yeah. No, and I think that certainly applies with physics and mathematics as well. And it is quite tough, isn't it? But I think maybe doing a really good marketing job in junior secondary as well, trying to encourage students that it's not, well, it is difficult, I guess. We shouldn't lie to them and say it's not difficult, but it's challenging because it's interesting, and it's interesting because it's challenging.
Yeah. Okay, we have also some questions here. I will choose actually, because I think we cannot do it all.
Actually, there's one. May I choose one from the chat? There's one about the explanations that we get in school on the way through can create misconceptions that we later on have to fix in higher school or in university, and that's certainly the case. I actually wrote a paper a few years ago called "Actually, It's Not Quite Like That," because what we do is explain to students, well, the atom is like shells. And then next year we go, well, maybe it's a little bit more complicated because there are subshells and orbitals. And then we go, well, no, it's not quite like that because there are quantum levels and, do you know what I mean? So we tell them something. Yeah. And then the next year we tell them, well, no, what we told you before is wrong. This is the new thing. So just thinking about how we can do that better, whether we can actually not do that process of recapitulating the history of chemistry, because that's really what we're doing. We go from sort of Dalton to
Rutherford.
Yeah, Rutherford and so on through to Bohr and so on. We don't necessarily need to do that. It's an interesting historical story. But we could actually start with a simplified version of our best current understanding of the quantum nature of orbitals and explain that at a level that's appropriate for junior secondary students, but not then have to correct ourselves at every level. So I think that's something that we can do in education, is do a better job. And certainly chemists and physicists at university can hopefully help with doing some translation and some simplification to teacher colleagues, so that the teachers actually don't inculcate these misconceptions on the way through.
Yeah. I remember once I was shocked because one of my students say that they can understand the shell of an item is like peeling a banana. So, this is maybe based on a certain process that she missed or things that she misunderstood in the earlier stage of her study. But that is a reality. Yeah.
Yes.
Also, another questions about the term scientific explanation and argumentation.
Yeah, I think I sort of, as I say, I try to distinguish on the basis that an argument seeks to have someone agree with you. An explanation seeks to have someone understand. So to me, that's my simple signpost. If I'm trying to get you to agree with my view, my perspective, my position, then I'm arguing. If I'm trying to make you go, aha, now I understand, then I'm explaining.
Okay, but not different with persuading. Yeah. Please,
yeah.
Chemistry, because it is beautiful.
Yeah. So, yeah, and our English colleagues might talk about what it takes in the persuasive essay and so on as well.
Okay. Anyone wants to ask directly, please unmute your speaker. No, this is also one question from chemistry student. Yeah, chemistry people. I don't know who are you, Sudria? Yeah. The hardest thing finding a high quality analogy to avoid further blocking in development of understanding conceptual. For example, electricity flow. Yeah, things like that.
Yes, no, I certainly had that one. That, and it can be quite challenging because the students develop their concept not out of nowhere and not only from what they learn at school. So I had a student who insisted that there is a positive flow of electricity from the positive terminal and a negative flow from the negative terminal, and they come together. And I said, well, no, in science we talk about just one direction of flow. And he said, no, but my dad is an electrician, and he told me there are two kinds of electric current. Well, that's his dad. That's the relationship. And he's an electrician, so he has some relevant knowledge. So that's quite difficult to overcome. So, the students' existing conceptions arise from a whole variety of experiences, and maybe also from a primary teacher who didn't fully understand the concept. That sometimes happens. So it is quite challenging to correct those misconceptions. This approach of testing multiple candidate theories to find the correct scientific theory, I think helps a little with that. And then using our analogies carefully. So if we talk about the hose, when a hose leaks, it's different from when a circuit leaks electrons out to ground, for example. That the analogy sort of works, but it doesn't work for everything. So.
Yeah, okay, thanks. Yeah, because sometimes it is not easy to find an example for chemistry, for example, for chemistry explanation. For physics and biology, it is quite a lot. Yeah, around us. For chemistry, it is because the thing is something we cannot see, we can explain only, and it is getting more complicated. Well, we want to explain clearly how an electron will be released or taken. Yeah, it is.
Yeah. I think in chemistry, the literature has moved towards representation as the issue.
Yes,
I think because it's about representation at these multiple levels. I think we're probably almost out of time, but I think that more than explanation, the chemistry literature really talks about how do you represent these micro processes at the macro level and vice versa, and translate between those, and then the symbolic level of equations as well.
Yeah. Okay. Actually, well, I still have another questions. Yeah, this is about ethics. Yeah, well, actually, chemistry people, if we see the history, chemistry people is the best contributor for environmental pollution, for example, because we understand more about how to make materials, how to modify materials, how to explore and exploit metals in minings. Yeah, then we know how to create new advanced material without thinking about the side effect in the long run.
Yeah, no, I think that's a really interesting question. That I guess I actually left out one of the elements of science, because I talked about development of skills and I talked about conceptual understanding, but I didn't talk about that human connection. So certainly ethics, how do we use our science? If we're biologists, how do we work around life and all of the complicated issues of life? If we're chemists, how do we work for the light side, not the dark side? How do we, improve the world rather than make another toxic substance that makes somebody a lot of money but damages the environment, and so on and so on. So yeah, I think, and this is something we really need to, it's probably another talk at another conference, I think, but something about how we inculcate in students those values of valuing one another, people more generally, people around the world, and the environment, the global environment. So it's absolutely crucial, and it's something that sometimes is neglected in the race to the examination, but it's a crucial part of science education.
Mm-hmm. Yeah, it is an important issue actually. But in your opinion, from what stage actually we should introduce ethics?
I think early.
Early.
There's a concept that we use when raising our own children, which is called filling the moral storehouse. That if you say to your child, "Don't run in the supermarket," because I said so, then they're only going to stop running when you're not there to tell them so. But if you say to your child, "Don't run in the supermarket," because you might run into somebody and knock them over, and that person might be old or frail or small, then you fill the moral storehouse, because the child now is thinking, all right, I should consider other people. I should think about the effect of my actions on other people. So do you know what I'm saying? That we can actually inculcate ethics right from birth, but certainly from the beginning of schooling, in those kind of ways, thinking about what's the effect if I throw out my drink wrapper on the ground, on other people, on the environment, and so on. So you start sort of developing those, and then it gets more sophisticated and into moral reasoning as we go higher in education, but all the way, I would say.
Yeah, but that's not chemistry. But for chemistry in higher education, for example, how can we introduce ethics in the curriculum to make more to ask them to be aware of the consequences consequences or of our research?
Yeah, I think,
In
I mean,
opinion-
ideally it's written into the curriculum. Ideally it's part of what the university is offering to the students. But I think in practice, many times it is individual staff saying something kind of incidentally. You know, that our topic here is organic chemistry 303. We're talking about nucleophilic bonding or whatever. But then we'll throw in something about the ways in which we deal with oil or various other organic substances. Do you know what I mean? That it can be incidental and it can be on the ethics of the individual lecturers as well.
Yeah. That's what I'm thinking about ethics. While we are having so many new chemistry lectures, especially with materials, advanced materials, and the the development of chemistry as science itself actually a lot, recently. So we have to be careful of it. Yeah. Okay.
Dr. Suryani,
Yes.
may I have one question, please?
Yeah, sure. Mr. Abidin.
Okay. Hello, David. Thank you for the enlightening presentation. Actually, maybe I'm shocked because maybe so far I mess up between scientific explanation and scientific argumentation. And maybe I use this interchangeable. So may you give me a signpost maybe to clearly differentiate between the two terminologies, because I'm afraid I use it before. Maybe I classify it as explanation, but maybe argumentation and vice versa. Yeah, thank you.
Yeah, no, I think that's as clearly as I can make it. That that explanation is particularly from this constructivist view. So this is what our German colleagues are talking about. Is that what I'm doing when I'm explaining is giving the student experiences and words, because that's the other thing. When we teach science, somebody said that in a science course, students learn as many new words as they do in a foreign language course. Like, we don't often think about it, but learning science is learning scientific terminology and what it means and making sure that it's meaningful for the students. So when I'm explaining, I'm giving the students the materials to build an understanding in their own mind. And in a way, they don't have to believe in it. Okay, I'm going to get very controversial and I might get thrown off the conversation because I know that evolution and creation is a complicated issue around religion and life and all sorts of things. I want students to understand the evolutionary mechanism. They don't have to believe in it. They don't have to believe that it's how life got here and how life got to be complicated. I don't require them hand on heart to, I believe in it, but I want them to understand. And so to me, that's the difference between argumentation would be, I want them to believe, I want them to accept, I want them to join my side, whatever. Explanation is, I want them to understand. I want them to be able to explain to me what natural selection means and how it would operate in a particular situation and so on. But is that a helpful example to think about the difference between the two things?
Yes, it's helpful. Maybe it's okay to say that explanation is like a scientist explain a scientific phenomena. So whether people understand it or not, or accept it or not. But when I do argumentation, maybe some psychological aspect involved, because how to persuade people to accept our explanation, our argument. Is it correct?
Yeah, I think so. I think that's a great one. So the explanation is in that domain of understanding why when uranium undergoes fission, it has particular products and some of those are radioactive. Like, that's the science part. The argumentation part is convincing people that those radioactive wastes that last a long time are a problem that we should take seriously. It's that socio-scientific connecting to human connections. Yeah.
Yeah, thank you very much. Yeah, that's make me more clear at the moment. Thank you.
Excellent.
Thank you, everyone. I think the clue for us. Well, well, okay. We come to the end of the speech. Yeah, thank you, David, for this enlightenment speech. How to develop students' conceptual understanding. It is very useful for us, especially chemistry people. Thank you, everyone, for the attention. I want to give the time back to Rivka as the master of ceremony.
Okay, and then special thanks to David. Sorry to interrupt your vacation. I know you're in long vacation now, but you spare time to us. It's we are truly grateful to have you here. Hopefully, we can invite you someday in Malang in the future. Yeah, yeah. Hopefully, in the near future. Yeah. See you again and enjoy your holiday.
Perfect. Thanks very much, all. I've thoroughly enjoyed the conversation. I wish we could go longer. Enjoy.
Okay. Yeah, thank you.
Enjoy the rest of the conference.
Yes, thank you.
Yeah. Rivka, I give back the time to you.
Thank you very much, Dr. Suryani. Ladies and gentlemen, before we start our second plenary sessions, I have some requests from the committees that we will have another photo shoot session. So please turn on your camera. Okay. Committee, ready? Okay. I will count on 3. 1, 2, 3. Cheese. Okay. Again. 1, 2, 3. Cheese. One more time, perhaps.
There's so many pages, actually.
There are 7 screens, so yeah, just keep smiling then.
Don't know in what page. Yeah.
1, 2, 3, cheese. Okay. 1, 2, 3.
Photo.
1, 2, 3, cheese. Okay. It's enough? All right. Okay. It's enough, ladies and gentlemen. Well, okay, I have some announcements, important announcements. Participants who have already presented in this platform are required to fill in the attendance link provided in the chat room. And participant also must fill in the registrations form and plenary attendance list on WhatsApp groups as one of the requirements to get certificate. Please fill it before 10 o'clock. Please. We also have a good news for you all because the submissions for the full paper date has been extended. So the deadline will be on 21st August 2020. So it's a good news for all. And I have also announcement for those who have not presented the presentations yesterday in the parallel sessions. You will be given a chance to do presentations today after the parallel sessions for today's finish. So just contact the committee and we will set the schedule for your presentations. Thank you very much. Oh, sorry. I think I have mistaken about the announcements for the full paper submissions. It wasn't 21st, but I mean it's 31st August 2020. Sorry. All right. For a brief moment, next sessions, we have second plenary sessions with our second keynote speaker, Dr. Chun Yan Chang from National Taiwan Normal University, Taiwan. We would like to invite our second moderator, Professor Dr. Herawati Susilo. Ladies and gentlemen, Professor Herawati Susilo is a senior lecturer in biology education. She pursued her PhD and master's degree at University of Iowa, United States, and her bachelor's degree in Universitas Negeri Malang. Ladies and gentlemen, please welcome Professor Herawati Susilo. Professor Herawati, the time is yours.
Thank you, Ms. Rivka. Good morning, ladies and gentlemen. Welcome to the second ICoMSE plenary session. My name is Herawati Susilo. In this session, I will be serving as your moderator. You'll be hearing a presentation from Dr. Chun Yan Chang, PhD. Before we get started, I want to read a brief biography of our distinguished speaker. Dr. Chun Yan Chang from National Taiwan Normal University chairperson. He is a professor of the Graduate Institute of Science Education, Department of Earth Sciences. And he is also Dr. Chun Yan Chang is the third professor of National Taiwan Normal University. He is also the director of Science Education Center. He is a professor of the Graduate Institute of Science Education and Department of Earth Sciences. He has been a visiting professor at the Taipei Medical University. Her major research interest is in science education, e-learning, interdisciplinary science, and science communication. Now, he is the editor-in-chief of the Eurasia Journal of Mathematics and Science and Technology Education, as well as the co-editor of International Journal of Educational Methodology. He is also on the editorial board of 3 SSCI level journals: Science Education, Learning Media and Technology, Journal of Science Education and Technology. He got his bachelor degree in Earth Science from National Taiwan Normal University, Taipei. And he got his master in Science Education in the University of Texas at Austin. And also there he got his PhD. His important academic awards is in 2008, Science 50, Scientific Achievement of National Science Council 50th Anniversary, and 2003, 2009, 2012, National Science Council Outstanding Research Awards in Science Education, and 2013, National Science Council 2013 Award for Excellent Contributions in Technology Transfer. The Academic Award of Ministry of Education in 2013. These are the significant publication from Mr. Chun Yen Chang. Before the presentation begins, let's note the regulation of how the presentation will be going on. Firstly, I would like to give the time to Dr. Chun Yen Chang to present the material for about 25 minutes. Now, allow me to welcome the speaker, His Excellency Dr. Chun Yen Chang, who will present the next generation of learning, cloud classroom. All right, Dr. Chun Yen Chang, now the floor is yours. Thank you.
Thank you, Dr. Herawati. Thank you so much for the nice introduction. And hello, everyone all over the world and Indonesia. It is my great pleasure to share with you my latest research and development in science education, especially actually applied in technology. So let me try to share my, so can everyone see it now? Okay. Okay. So can you see my PowerPoint now?
Yes.
Okay.
Can you do it? Can you speak louder, Mr. Chun Yen Chang?
Okay.
I couldn't read. I couldn't listen to yours.
Okay. So I will speak louder. Is it?
Oh yes. Thank you.
Okay. Okay. All right. All right. So what I'm going to present you for the next couple minutes is the latest development of we call it cloud classroom. So this is actually quite an interesting tool developed by my team. So we have been developing it for the last maybe 5 or 6 years already. So because I think today we have this online virtual conference, so maybe it's better for me to present this tool. Actually, this tool might be useful in terms of increase online interaction. When you are, doesn't matter when you are doing the lecture like this now, or you are doing you are teaching a course, or even students are doing some online learning. So I'd like to present you for the next couple minutes are the the cloud classroom. Okay. So before I do my presentation, I would like to show you a very quick video. I don't know if you can see it or not.
The Hawley-Smoot Tariff Act, which anyone raised or lowered?
So there's a professor doing a lecture in the class. But however, all the students, okay, maybe just like you sitting in front of the screen now, okay, feel bored, or you don't know what to do because the professor keep on lecturing. Okay, so this is actually from a quite famous movie. So this is why my group, we try to develop, we call it in the old time, the tool is called clickers. So everybody was passed some kind of like a remote control. Then when the professor present a question, okay, then all the students can actually let me move my camera a little bit in order to, okay. So the students can answer, and the professor can display how many students select A, B, or C, or D. Of course, it's kind of like a tool already in there for 20 years. Okay, so clickers is originally for a large class. So like, like 101 class physics with a 200, 300 participant, a little bit like the today's conference participant, we have like a 200. So then it used clickers, for the large classroom. But however, when 2008, the smartphone revolution begins. So many companies actually move their clickers into like so-called smartphone clickers. But however, I don't like the smartphone virtual clickers, the term for that. The reason is when we move to smartphone, right now we are doing this Zoom virtual conference, everything becomes quite totally different. Okay, so but I like to give you like several past example. So I don't know what happened. Okay, anyway, so always a technical problem. So if you want to, the most famous clickers research is actually done by a Nobel physics, American physics as a Nobel Prize, Carl Wieman. So he published a paper in Science in 2011. Okay, so he was he found out like the clickers can actually improve learning in a large enrollment physics class. Okay, my own research group, we published a paper actually in Educational Research Review. We try to do a review on clickers for the past 20 years. If you're interested, you can actually download this paper. This is an open access paper. So we actually do some meta-analytic review of clicker integrated instruction. Of course, we found clicker, if you excluding all the other novel effect, testing effect, all these other effects, you can, if you are interested, you can read this paper in detail. We found out that actually clicker itself actually are very good tool in terms of improve students' learning. So this is why 5 years ago, our group also tried to develop a tool, which of course is all times called clicker, but right now I call it Cloud Classroom, developed by my class, my team. So we have this Cloud Classroom was actually selected by 2019 Horizon report in the mobile learning area. So as an example institution. So for the next couple minutes, although time is very short, usually when I demo this Cloud Classroom, usually it's 2 or 3 hours, including detail, how you use that, the instruction. But however, what I'm gonna to do is like, I really like to interact with all of you, okay? For the conference participant using this new tool. So it's called a Cloud Classroom, okay? So what I want to do is I want to ask all of you online now, okay, to access this website, but please access the second one because we have a server in Singapore. It's called sg.ccr.tw. So what you can do is now, of course, you are online now, but of course, in addition to Zoom, you can open another web page. So please, of course, you can also use your own iPad, your mobile phone, any device, okay, which you can access internet just like now. Okay, so I want to ask you to access, it's called sg.ccr.tw. Okay, let me try to see if I can access from my side to show you the interface. Okay, all right. So seems like, okay, does everybody see that? See the Cloud Classroom interface? Okay. So if you see the cloud classroom, you will see student, teacher, and the guest. So what I would like to ask you to do is you can change your language. We have around 15 languages. We have also one language in Indonesia. So you can also use the Indonesia language for your own conveniences. Okay. So when you access the okay, I hope everybody is right now. So if you go into the sg.ccr.tw like the guest here, if you use only guest, you can just type your name. Then you will see join the classroom. Okay. So what I'm going to do is ask you to join the classroom. Of course, you can use your Facebook or Google account to join. So what I'm going to ask you is that please join classroom 100. Okay, so
I'm sorry,
yes.
we couldn't listen to you.
You mean no sound?
Yeah.
Can you hear me now?
Yes, now.
Okay. Maybe I should, I don't know, maybe the camera.
Maybe you have to.
Yeah, maybe I need to adjust my microphone.
Microphone, yeah.
Yeah, okay.
Oh, your time is not 25, but 45 minutes, Dr. Chun. I'm sorry.
Okay. All right, so I'm trying to see. Okay. Let me try to see. Okay. So can you hear me right now?
Yes.
Clearly?
Yes, we can hear you.
Okay. All right. So I will try to speak louder. Okay.
Okay,
so
thank you.
No problem. So please get into SG, as I say, sg.ccr.tw. Then please enter room 100. Okay. All right. So I already see some of you are already there, but not many. But please okay, do your best to get on the 100 right now. I see 8 students on my cloud classroom. Okay. So while you are getting into the sg.ccr.tw classroom 100, okay. So once you get in there, you can use it for free. This is like a free for everyone. So you don't need to download anything. The only thing you need to do is you type the website, then you can start use it. Okay. Now, if you use Facebook or Google login, then you can just use then you can log in as a teacher or as a student. Okay. All right. So on the top left button, okay, on the student face, you can show your emotion, okay, using different type of emotion. You can also send your private message from the left button to me, okay, while in the class, okay. Then, of course, you can also, then you can message to the teacher, okay. Then at the bottom, you can also raise a public questions to me. Then the most liked public question will be the most liked public will be on the top like here, public question will be on the top of a teacher's interface. Okay, so now I would like to do a small demo. If you are not if you are not using the cloud classroom, it's okay. You can also feel it, how to use it. Then you can use it for yourself. Okay. So here you can actually throw different type of questions. True, false, and the multiple choice question are the same as the old time clickers. But however, in the cloud classroom, we can use open-ended questions. We can use animation questions. So with the smartphone version, you can actually give out so many different type of questions, and you can actually ask this question instantly with your students. So as you can see here, if you ask these questions, then you can just like all clickers, then you can just display the results to the students. And the students can actually answer the questions with either their text or pictures. Okay. Then after student answering your questions, you can group students. Okay, you can group students based on if they are heterogeneous group or homogeneous group. So it's gonna be like, you know, all the different. Okay, so what I'm going to do is like, you know, I would like to use the SGCCR to interact with you. Although I know right now there are only like 7 students online, but I would like to still, you know, try this, okay, just a little bit, okay. So what I'm going to do is I'm going to give you a quick question, okay. All right, so I'm gonna ask a question like are you happy this morning? So what I'm doing, I'm not asking yes or no. I'm asking open-ended questions. Okay. So please, if you are using the cloud classroom right now, please answer it using your own use your own device. Okay. All right. So I already got some response now. Okay. Yes, I'm happy this morning. I'm so happy today. Yes, I'm happy today. I'm very happy to enjoy the day. Wow. Thank you so much to all of you to answer this my, you know, quick questions. So then I can actually, so, you know, because we don't have so many people online, I can just, you know, display, okay, on your own device. Then you can see, you know, all the students' responses. Okay, with that, you can actually do a lot more different things. Okay, so our cloud classroom right now is very advanced in terms of, you know, if you know, true, false, and multiple choice question, it's easy. But for open-ended answers, we can actually do some semantic clustering students' answers. So then we can group students based on their different semantic answers. Okay, then student can do selfie checking. They can do role swapping. What I mean role swapping is like, you know, I can assign one student as a teacher. So one of you will be assigned as a teacher later on, okay, to give a question, so let you try. So we believe that if students can raise good questions as teachers, means like, you know, they understand the topic and also the course, okay. And as a teacher, you can download all the students' records. So we also have some animation-based questions, okay. So if you are online, maybe I can give you a quick demo on the open-ended questions. No, on the animation question. So there's let me show you one small animation questions. I don't want to. Okay, let me see. Okay, so this is a small animation questions. So students can actually use this animation. Okay, so this is a DAS exploration animation. So if you are, on the CCR, you can also try yourself. So this actually moves everything, not only learning, teaching, but also assessment online. So this is quite exciting. Also, PSI, a couple years ago was proposing collaborative problem solving. So our cloud classroom also have some collaborative problem solving. For example, we have this, so I'm gonna end that question now. So I'm going to give you an example if you are in CCR, okay? So you can look at this seesaw questions, okay? The seesaw questions actually try to group students to solve the seesaw question. So one student will be on the left, one student will be on the right. So they try to discuss how to balance the seesaw. So you can also see, on your own device, if you are one of those 7, 8 students, you can also experience that, okay? All right, so these are some like our development. So you are more than welcome to use this cloud classroom by yourself. The reason is like, it actually has evidence-based research showing that, this type of tool can really improve students' learning, not only face-to-face now. Right now, when we move in online, I tried it several times for the past months, okay, because of the COVID-19. It also works quite good, okay? So finally, I want to introduce, but I'm not gonna demo that. So we try to put some gaming element in the cloud classroom. So makes the classroom learning more fun and more challenging. So just like maybe some of you know Kahoot. Kahoot is kind of like a gaming, but Kahoot is using all multiple choice items. Okay, it's easier to do the gaming. But however, our gears, the gaming module actually can leverage it now, not only on true, false, multiple choice. In the future, we also can use open-ended questions, animation. So it's all in the plan. So you are all also welcome to experience that. Okay. So then we also have like, website. If you are interested in, you can, get on that. Okay. So originally I want to try this different question with you, but now I'm going to skip it. I want to show you some of the good use for cloud classroom. For example, you can use with your SSI lesson, social scientific lesson. Okay. And using this has been showing you can improve students' argumentation skills. Okay. And of course, this can also solve, like, most Asia students, they are silent in the classroom. But however, when they are using this new tool, they are not silent anymore. Okay. Because in Asia, students usually like, afraid of giving peers a bad impression. They want to just like a normal student. Okay. So because of this cloud classroom, it's actually quite good for all the different types of teaching and the learning. So traditionally, the best practice for using the cloud classroom is you ask questions, then you maybe vote, you do some peer discussion, you vote. But our group, it's also another research published in Eurasia Journal. So we can vote individually, display result, peer discussion, revote, then display the result. So you can actually doing all the different kind of modified peer instruction. We did that with Newton's law. Okay, and we also ask, after students vote, we also ask them to do some experiment to try to solve the problem. Then after student doing this hands-on activity integrated with cloud classroom, you can see student learning progress, okay? From question 1, 2, 3, it's all becomes good and good, okay? So finally, the final research, okay? Before I exit the cloud classroom demo, I want to ask one of you to ask a question, okay? So this is a latest research done by myself and my just my former doctor student. He just got his PhD with me in June. He's right now going back to University of Denver. His name is Bevo Wahono, an excellent, my excellent teacher, my excellent student. So as you can see, we actually submit this paper to JUST. We hope right now we have a right now major revision. So this is kind of like we're using cloud classroom to do some like, effective practical assessment. Okay. So we did some like, how do students, okay, experience in this social scientific based instruction, okay, STEM 6E, and how does this is this instruction effective in terms of improving students' outcome, and how about students' perception, okay? So we actually use this with the cloud classroom, okay, in Indonesia, okay. Then the cloud classroom not only used as a teaching learning tool, it's also used as a data collection tool. So as you can see, this is the research we have done in Indonesia. Okay, so we have also some hands-on activity. Okay. Okay. So the 6E model, the STEM 6E model, including engage, explore, explain, engineering, enrich, elevate. So this is the result for the SSI-based instruction. As you can see, for all these 4 different classes, actually the STEM 6E with cloud classroom is effective in terms of improving students' learning outcome. Okay, and with coherence D in terms of effect size. In the proximal concept, okay, it's actually quite large, strongly, very powerful. Okay, all right. And the students' perception after the instruction also, they have extended the STEM content and engagement, and including all these other perception. So this is one of our latest results. Okay, the social scientific based STEM 6E model interacting with cloud classroom is quite a positive classroom activity. So right now it's actually under revision by JUST. Okay, all right. So I think I already did my presentation for 40 minutes now. So I would like to assign one of you in the cloud classroom as a teacher. Yeah, if you are still there, could you please get down the cloud classroom? So right now I'm assigning Ika. Is Ika or Ika as the teacher? You can ask the questions. Okay. All right. So finally, how things have changed. So in the old days, okay, everybody celebrating birthday, and nowadays, they are checking on Facebook. Okay. And before you ask your dad who made the word that, then they answer. But nowadays, your dad will say, Google, my son. Okay. How things have changed in 1961. Okay. When your kids are not doing good in school, the parents will spend the kid. But now it's the other way around. Okay, so they complain the teacher. So man versus TV. Right, in the old days when I was a kid, okay, your mom said go to your room. Okay, lonely. But nowadays, go to your room. Kids are very, very happy. Okay, so technology have changed a lot. Okay, for example, clicker, cloud classroom, they can get student attention from avoid the doors off, and you know, you can engender better discussion. But of course, if you are too focused on technology, it's not going to be good. Okay, some people already warn that. So you use only technology when it is appropriate. And we believe that technology like cloud classroom has its usefulness. Okay, if you use it wisely in your class. Okay, of course, education ugly. We don't want to make students all the same. We try to bring more technology, diversify all the different teaching vendors. So we don't want to reinvent the wheel. Okay, we don't want to look at this like, you know, you thought you have evolved, but you are actually not for the nowadays. Okay, all right. So this kind of like conclude my talk, and I'm willing to take any questions. But seems like Ika, you did, I don't know, maybe you don't know how to give the answer, but that's okay. You can just try out Cloud Classroom by yourself. Okay. So I think I will end my talk now. It's around 30-40 minutes as requested by the host. Okay. So I'm ready to take questions. Thank you so much.
Thank you very much, Dr. Julian Chang, for giving such informative and interesting presentation. Ladies and gentlemen, now we can come to question and answer session. You can type the question in the chat room, or you can directly ask Dr. Julian Chang.
Okay.
Maybe you can unmute yourself and then speak. Okay. Yeah. No one asked directly. So I will read the question from chat room. Explain the evidence. Bukan ya? Bukan itu ya.
Okay, so I saw the first question. What are the disadvantages of using cloud classroom?
Yes.
Yes. All right. So I mean, I can answer this two different ways. The first way is a more general way, like, you know, it's like all technology enriched learning has this kind of disadvantage. Like, you know, sometimes because of a novel effect, when students encounter a new technology, they always feel like, wow, exciting, interesting. But when times, you know, goes by, maybe they don't feel that exciting anymore. So all the technology, as I have said, like, you know, you need to use it wisely and appropriately. You don't use it like, you know, like all the time. So like a cloud classroom, we have found out that if you ask good questions, okay, and using good teaching strategy instruction with the cloud classroom, then cloud classroom is very, very good. But however, if you don't design good questions, you don't use appropriate instruction, maybe that's not good. Okay, that's the disadvantage. And another disadvantage of cloud classroom is like, you know, you need to have just like I have demo, you need to have one device. Every student need to have one device, access the internet. And the internet, of course, the speed doesn't need to be very fast. But however, you need to have some, like, you know, appropriate internet speed, access speed. So if you don't have those two, then you don't need to use cloud classroom because it's useless. Okay. So this is also one of the major drawbacks of the technology. It always requires some hardware, software, nowadays also internet. So these are the disadvantages of cloud classroom. Okay. So how to combine using cloud classroom with the experimental class? Okay, very good questions. I didn't have time to go through the study we have done. So I want to give you a more detail. Like, as I've said, the cloud classroom, you design good questions, okay? Be it multiple choice questions or open-ended questions. It's all okay. But however, when you design good question, then usually you need to display the results. Yeah, because like one class of students, 40, 50 students, they have all the different answers. Excuse me. They have all the different answers. So you display different answers, which means like you enlighten students with, wow, so many different answers from my peer students. Then students know they have different answers, just like the SSI class, social scientific issues. They have different opinions. So then you try to group students, okay, to discuss. When you group students discuss, they may think, oh, maybe I can do this kind of experiment. Or maybe teachers can provide some pre-designed experiment for them. So this is how we did for the Newton's class. Students improve their learning. So when they have some misconceptions, they can do the experiments to sort of like correcting their misconceptions. This is how it's done. So when you are doing cloud classroom, usually, of course, you design good questions, you ask good questions, you get students' responses, you display student responses. Then, in order to correct their misconception or in order to lead them to the more correct way, then you can give them some experiment to confirm or disconfirm or disapprove the results. Afterwards, student can come back. Then you can use cloud classroom to ask question again, to vote again. So from our experience, also from Carl Women's science paper, we found out that when students they don't originally know the answer, but then when they do discuss or when they do experiment, it's actually helping students learning more. Okay, so I have
Kak Karunia.
yeah.
What to combine here
If
today?
you want to try for your physics class, you are more than welcome to do that. And if you are interested in using cloud classroom in your own class, or if you want to do research, you don't need to email me. You can just use it. It's everybody's. Everybody can use it. Okay. And right now we are still improving the system, so to make it more more powerful. So you can check once in a while, every 3 months, 6 months. We also have some small improvement for our cloud classroom.
Okay.
All right.
Are there somebody else who want to ask questions? Dr. Chun, I tried to get to your class, but I couldn't.
Okay. Yeah.
I don't know because of the maybe the internet.
Right. So this is one of the major drawbacks.
Yeah, maybe I will try someday.
Right. Maybe sometimes if the internet connection is not good. So, but that's okay. I think right now, you can use it in your own class because cloud classroom is majorly, okay, it's mainly for face-to-face in classroom interaction. But however, later on, we found out that we can also use it for the online situation like this, or in the museum, field trip, you can all use this as long as you have a device and you can access the internet. If you have those two requirements, then it's actually quite easy to use.
Okay, is there somebody else who want to ask questions? Nobody? Okay. I think now we have another tool for teaching, especially during this their online teaching and learning. Oh, there's another one.
Okay.
Yeah, this platform applicable when the internet connection is not too strong. Is this platform applicable when the internet connection is not too strong?
Yeah, well, okay, so I think there are two, actually I also got another private message. So I think that's also a good question. He or she was asking, will CCR reduce the social skills of students because they just interact using machine to machine? How to keep students' social skills development? Yeah, I think that's a quite a good question in terms of, you know, you don't want to students only interact with a smartphone, right? Yeah, because or with a machine. The reason is like, you know, every kids now, I don't know if it's the situation in Indonesia, like every kids right now interact with only the, you know, the phone. Okay, if you get on the subway, on the bus, so I'm totally with you. Like, you know, so this is why when you use cloud classroom, you don't use it all the time. You try to interact, you try to integrate with some kind of other online some other hands-on activity or experiments or, you know, group discussion face to face, in order students to still, you know, maintain or increase their social skills. Okay, so one other question is this platform applicable when the internet connection is not too strong? Okay, so usually, as long as you have internet connection, it's okay. Then actually, mainly text-based. Text-based means like, you know, if you only use text, you don't use picture, video, you don't need a very strong, very powerful internet connection. Okay, but if you use video, some like big photos or animation, yes, you do need like, you know, more strong internet connection. But however, with only text-based, you don't need a very strong internet connection. It's okay. You can try yourself.
Okay, thank you. Is there somebody else who want to ask question? Okay, finally we come to the end of the second plenary session. Before I close the session, I would like to take the conclusion from what the speaker has presented. One is we have a new tool to teach during this COVID pandemic 19, especially for teachers and for all of us. We can use the cloud classroom without permission from Dr. Chun Yen Chang. We already have the link. We can use it. Thank you very much, Mr. Chun Yen Chang, for this new tool. Also, we can use it like Kahoot for quizzes. Like for quizzes, we can use for many types of questions. Also, we have new things. GEARS. That's a very good game. We can try to use this also.
Yes.
Thank you so much, Dr. Chun Yen Chang, for giving us that very important tool for our teaching and learning processes.
Thank you so much for inviting me.
Yeah, thank you very much, Dr. Chun. We really appreciate your time and work.
Okay,
thank you so much. Now I want to return the time to Ms. Rifka. Thank you very much, Ms. Rifka.
Thank you very much, Prof. Herawati Susilo. Ladies and gentlemen, before we start the third plenary sessions, I have some information to announce. There will be a award for the best presenters for the each parallel group, and also there will be 10 best participants from the first until this day, mainly based on your activity in plenary sessions. So the committee will announce the awards via websites or WhatsApp groups. So just stay tuned on our websites. All right. Next sessions is our last plenary sessions for today, which is with Associate Professor Bambang Sumintono, PhD, from University of Malaya, Malaysia. We would like to invite our last moderator, Ms. Latifah Mustafa Listianto. Ladies and gentlemen, for your information, Ms. Latifah Mustafa Listianto is an assistant professor in mathematics education department. She got her master's and bachelor's from Universitas 11 Maret. Ladies and gentlemen, please welcome Ms. Latifah. Ms. Latifah, the time is yours.
Thank you, Ms. Rifka. Assalamualaikum warahmatullahi wabarakatuh. Good morning, ladies and gentlemen. Welcome to the last ICoMSE 2020 plenary session. First of all, I would like to introduce myself. My name is Latifah Mustafa Listianto from the Mathematics Department of Universitas Negeri Malang. In this session, I will be serving as your moderator. You'll be hearing a presentation from Mr. Bambang Sumintono, PhD. Before we get started, please let me to read a brief curriculum vitae of our distinguished speaker today. Okay, can you see my PPT? Mr. Bambang Sumintono, PhD, is currently a lecturer at Education Faculty of University Malaya, Malaysia. And this is the personal information of Mr. Bambang Sumintono, PhD. He has received his bachelor degree in chemistry education at Universitas Terbuka Indonesia and taken his master degree in education administration at Flinders University, Australia. Then got his PhD at Victoria University of Wellington, New Zealand. He also an active member of Educational Assessment Evaluation and Accountability Journal. And his personal interest of research are in science education, lecturer reflection, and RAS model objective measurement. And he also is the author or co-author of many articles in the fields of educational research, as you can see on the PowerPoint. Here are some of his articles. And he is also a reviewer for international journal. As you can see on the slide, one of this journal is School Leadership and Management Journal. Okay, this is a brief curriculum vitae of Mr. Bambang Sumintono, PhD. Without further ado, now allow me to welcome the speaker, His Excellency Mr. Bambang Sumintono, PhD, who will deliver a presentation entitled Objective Measurement for Cognitive Tests, an introduction for about 40 minutes. During the presentation, if anyone has questions or comments to Mr. Bambang Sumintono, PhD, please write them down in the chat room. To all participants, may I kindly remind you to mute your microphone, please, and give full attention for the presentation from Mr. Bambang Sumintono, PhD. Please, Mr. Bambang Sumintono, PhD, the time is yours. Thank you.
Okay, hello. Okay, thank you very much, Madam Moderator. Right, so Assalamualaikum warahmatullahi wabarakatuh. First of all, I would like to say thank you to the Dean and then Pak Habibin and all the committee members for inviting me to share about the objective measurement, right? So just trying to share what introduction regarding objective measurement. So to let you know, I'm Indonesian, so I originally come from Bandung. So maybe I just use double language with you, all right? So I know that from morning to up to now, so you listen fully English with the conversation, right? So sometimes it's memory burden for you, right? So to make it relax, so I share something in bahasa too, right? Actually, I plan to go to Malang, and then with this conference, I just imagine myself with my wife and kids go to Bromo, right? So very interesting, vacation. But come COVID-19 pandemic, so we have to do it online, right? Okay, so I would like to do sharing my presentation, right? So anybody can see the my presentation?
Yes.
Right? Okay, and then the next one is it my voice is clear? Can hear clearly at your side?
Very
All right.
clearly.
Okay, so because the previous speaker, I think they have some sound problem. So, all right. Okay. So I would like to share a bit about this one, because if I talk about this, I can teach you 2 semesters, and I think I don't have time for that in this small occasion like this, right? So what is objective measurement is just an approach actually regarding how we can get a precision and accurate measurement. Okay, kita berbicara tentang pengukuran yang teliti dan tepat. Okay, why? Because most likely we've been taught about that the way we have scored is actually reflecting our ability, which is based on what we call classical test theory, right? So we are not talking about chemistry education or mathematics education or physics education or biology education. We are talking about how we measure that the student really understand and they have the indication of the progress about what they learn. There's talking about assessment and measurement, right? So you can see my name there, and then my email, and also my blog if you like to visit. Okay, if you have any question, want to discuss, want to ask something, just email me. I'm very happy to help you and to share something, right? So I think this thing already informed by the Madam Moderator. So actually, my background work is a teacher, right? So could be some of you are originally come from Lombok. So I teach at Lombok for 7 years as a chemistry teacher at SMA, right? So it's not in Mataram, it's a bit far away. So I think I can still remember my school is surrounded by paddy rice, dikelilingi sawah, right? So it's when you are young, so it's really what you call as interesting experience to have that, right? All right, so okay, so in the last 3 years, I become editorial board member for 2 journals, but the first journal, School Leadership and Management, because at the moment I'm more focused on school about educational assessment, so I just choose the last one, which is about educational assessment, evaluation, and accountability, which is a top journal in educational assessment, right? Don't worry, become a reviewer and editorial board member is what we call as a pro bono activity, right? So it's just mostly about our expertise contribution, right? Okay, so I start this with the story, right? I think maybe some of you think are millennials, so born after 1983. So I am what we call a born post-colonial. So not really what we call as similar background with you, right? So the story behind this incident is that the flight, which is Air Canada Flight 173, traveled from the east side of Canada to the west side of Canada. In the middle of their flight, they lose engine capacity. Both of the engine is turned it off, right? Can you imagine, for example, tons of plane, okay, carrying close to 200 passenger, right? Lose their power to fly, okay, in the middle of the sky, okay. So, and then they have to do what they call it as emergency landing, pendaratan darurat, okay. And the further investigation, this is because the personnel who have to refilling the flight, right? So orang yang diminta untuk mengisi bahan bakar pesawat tersebut, they confuse regarding the unit, right? So all of us tend to understand easily regarding unit of weight, like kilogram or liter, that kind of thing. In North America, they also use not only kilogram, they also use pound, right? So the instruction to refill the flan is in kilogram, but the personnel, the officer who refill the flan is using pound. So 1 pound is equal to half kilogram. So can you imagine that, for example, the flan have to refill around 1 ton of kerosene, okay, sekitar 1 ton bahan bakar, tapi karena yang digunakan adalah satuan pound, maka yang diisikan hanya 500 kg bahan bakar, right? So that's the reason the flight is losing their power to fly, and then they are do some what we call emergency landing in the place called Gimli. So the incident called as Gimli glider, right? So this is telling to us that unit is a very fundamental thing in physics. Satuan adalah sesuatu yang sangat esensial dalam fisika, right? Right. So next one, That's the stories about physics. But when we try to measure about human being, right? Pada saat kita mau mengukur manusia, we are not measuring something visible, right? Of course, as a human being, they have a physical properties like height, weight, volume, temperature, that kind of thing. So now everywhere you go, because of the COVID pandemic, so you have to do some temperature checking. Okay, if you want to enter the building, enter the what we call as certain room, right? This is something become routine now. But we are not talking about that physical properties. We are talking about non-physical properties. Okay, so non-physical properties. The first one is cognitive ability. Okay, like intelligent, right? Ability to solve problem. Okay, ability to speak other languages. Okay, and the next one is about non-cognitive ability, measuring attitude, opinion, and perception, right? So in this case, we are more concerned about cognitive ability. Okay, so kemampuan kognitif adalah sesuatu yang tidak nampak, sesuatu yang tidak terlihat, hidden, latent. Okay, how do we know we measure better when we know that what we measure something not visible? Bagaimana kita tahu kita mengukur dengan baik, dengan valid, kalau yang kita ukur itu sesuatu yang tidak terlihat, yang tidak nampak. Oke, ini adalah sesuatu yang sangat serius dalam konteks pengukuran manusia. Oke, so sometimes we just take it as granted. We don't really sure, and we just put it as face value that what we measure actually something correct, but right. So when we talk about measurement, we are talking about quantitative research. In quantitative research, most likely we are dealing with variable. Okay, so everything regarding measurement regard to variable. Okay, peubah. Okay. Kalau kita berbicara tentang variabel, maka ada 3 hal yang terlibat secara langsung. We have to talk about conceptualizing variable, definisi daripada variabel. Oke, ini sifatnya adalah kualitatif. Yang kedua adalah mengukur variabel tersebut, yaitu kita berbicara tentang instrumen. Kalau misalnya saya ingin mengukur kemampuan berbahasa Inggris, maka saya menggunakan instrumen seperti tes TOEFL, okay? Tes TOEIC, atau IELTS test. Okay? Kalau saya ingin mengukur kemampuan matematika siswa, maka saya memberikan dia adalah soal-soal matematika. So we are talking about instrument and measurement, right? The last one is we already got the data. Then we want to prove something. So we study about relationship. So most likely we are talking about inferential statistic. Okay, which one is better in terms of achievement, boys or girls? So we use, for example, ANOVA test or t-test. Maybe we do some kind of correlation. Okay. Is it English ability connect with the mathematical problem solving ability? So we use relationship. In this term is correlation. All right. So that's kind of thing that when we deal with variable. Okay. Then when we know we want to measure something, pada saat kita tahu kita ingin mengukur sesuatu, so kita mencari instrumen apa yang cocok. Okay? In terms of physics, we know that we from beginning are using a standardized instrument in physics, right? So like a ruler on the left hand side, and then watch to measure time, and then thermometer to measure temperature, and then weight scale in order to measure weights, right? So if you look at this four instrument, it telling us about something universal. It telling us about good quality measurement. When you can measure something in Malang, the result of measurement easily understood by somebody who live in Kuala Lumpur, right? So for example, you are talking about measuring a pencil, and then you mention that the length of the pencil is 10 centimeter. It's easily understandable for somebody who are living in Kuala Lumpur or in London, right? Okay. Okay, and then when we talk about this measurement, we have to think what is the characteristic of this instrument in physics. Apa ciri-ciri pengukuran dengan instrumen di fisika? Okay, so if we see this kind of thing, we know that the first characteristic of all instrument in physics, they have the starting point. Semua instrumen dalam fisika, dia mempunyai titik awal, titik nol. 0 cm, 0 detik, 0 derajat Celcius, 0 kilogram. Okay, that is the characteristic of a good instrument. Okay, the next one, they have scale. Dia mempunyai skala. Skala bermakna jarak yang sama, right? Meaning equal distance, equal interval. The distance between 0 to 3 centimeter is equal like 3 to 6 centimeter. Jarak dari 0 ke 10 detik sama seperti jarak 30 detik ke 40 detik. Okay, so that's the second characteristic of the instrument in physics. The third characteristic, they have unit. Okay, if you want to measure length, you can use inci or you can use centimeter, right? If you are talking about a longer situation, you can use meter, kilometer, or that kind of thing. But all of it have equal distance. Okay. The similar thing like what you have in terms of measuring time, you have second, minute, hours, and days, for example, and the rest. Okay. So the last one, all the instrument in physics, they are linear, garis lurus. Okay. So these four characteristics showing something that instrument in physics have a good quality of measurement. Okay, starting point, scale, equal interval, unit, and linear. Okay, we talk about something that relate to physical measurement, and then we have to go back. We are measuring something hidden. We are measuring something latent. For example, I want to measure student ability to solve mathematic problems. How can we apply, right, the characteristic in physical measurement, okay, into the something hidden, something latent, right? So there's our problem. So how do we know the quality of our measurement showing something has a precision and it is accurate, right? So that's the problem, the thing that we have to find a solution. Otherwise, we can do something what we call as not bring good to the person who do test, for example. Kalau kita dalam kondisi tes seleksi masuk Universitas Negeri Malang, bagaimana kita yakin bahwa mahasiswa yang diterima memang berkualitas? Okay, we cannot just rely on the score, because score is only give you a summary of the result, not the detail of the result, right? So that's two different things, right? So the next one, how do we know we approach regarding the measurement using the correct and appropriate model, right? So I use the concept from Mark Wilson in his book published in 2005. The title is Constructing Measure, right? So it is Mark Wilson is a professor at University of California, Berkeley, right, in US, and he wrote about that book, and then he talked about what we usually call as 4 building block. Okay, 4 building blocks meaning that is a guidance how we develop the instrument, and then how we make sure that the process of developing that instrument are following a correct and precise procedure, right? So he talked, the first thing is about construct map. So construct map, for example, when we measuring somebody who are good in mathematics problem solving, so we have to imagine that the range of that variable could be from starting somebody who cannot do any mathematical problem solving to somebody who are going up, which is very skillful in terms of doing mathematic problem solving. So we have to imagine like a kind of spectrum. Kita harus membayangkan bahwa yang namanya mengukur variabel kemampuan pemecahan masalah dalam matematika itu mempunyai spektrum yang bergerak dari orang yang tidak mampu mengerjakan sampai kepada orang yang sangat pandai memecahkan masalah matematika. Oke, kita harus pandang spektrum seperti itu. Atau kalau dalam tes bahasa Inggris adalah orang yang tidak bisa berbicara bahasa Inggris sama sekali dengan orang yang sangat fluent dalam berbahasa Inggris. Okay, that's what we call about construct map. Okay, the next part is what kind of test that we want to be give to the respondent, to the student. We call about item design. We want to do the what we call as essay test, right? Or we want to do the what we call multiple choice test, right? So we have to decide what kind of test item that we want to develop. Okay. And the next one is we have to decide how about the scoring. Okay. So most likely if you deal with multiple choice tests, so the scoring is 1 for the correct answer and 0 for incorrect or not giving any answer, right? So in essay test, we have what we call a rubric, okay? The next part is we call it as a measurement model. How we approach the data, the raw data we have, and then can interpret appropriately and correctly. Okay, so that's the discussion about construct map. All right, so when we have the data from cognitive test, most likely it is a ordinal scale. So what happened in ordinal scale? So many abuse, so many inappropriate procedure are doing it. Okay, as you can see on the left side, they are telling something simple. Finding mean and standard deviation is inappropriate. If you see on the right hand side, it is a foundation of misinference. Meaning is you are doing it correctly, and then the finding is not make sense, right? So it is a very big question if you are doing quantitative research, if somebody are telling like that, right? So another approach that we can use, usually we call it as measurement model, which is classical test theory, okay? So giving like what Spearman explained, the second one is Cronbach, and the third one is Thurston, okay? All these classical test theories actually provided what we call group-centered statistic, okay? So when you are playing with software like SPSS, what you have there is only group-centered statistic. Saat Anda menggunakan software statistik inferensial, itu tidak lain Anda menggunakan pendekatan group center statistik. Oke, contohnya misalnya Anda mempunyai data yang banyak dari 500 orang, lalu Anda melakukan uji ANOVA, maka yang Anda dapatkan hanya nilai F-test. Anda mendapatkan informasi dari banyak data, tapi satu indeks saja yang Anda dapatkan, yaitu group center statistik. Anda mempunyai data dari 500 orang, mengukur katakanlah kemampuan bahasa Inggris dan kemampuan memecahkan masalah matematik, Anda korelasikan, maka Anda hanya mendapatkan nilai R value saja, nilai R kecil saja, indeks korelasinya. Oke, itu adalah informasi yang terlalu kecil untuk bisa dijelaskan dalam jumlah data yang sangat banyak. Oke, apalagi kalau kita berhadapan dengan desain riset yang sifatnya pre dan post. Right? So if we have pre and post situation, so we do some treatment and we got data from pre-test, and then we do some treatment and then we have another data from post-test. Then we do ANOVA test or t-test to compare is it the treatment is working or not. And then we have F value telling something it is significant or not significant. Right? So that's the approach, we call it as group center statistic. Dengan analisis seperti itu, kita tidak bisa menjelaskan siapa yang berubah. Dengan analisis seperti itu, kita tidak bisa menjelaskan berapa banyak perubahan. Dengan analisis seperti itu, kita tidak bisa menjelaskan mana soal yang berubah tingkat kesulitan. So this means that group center statistic is limited information you can get and use to report your findings, right? So you have to be skeptical, you have to be critical that the regular statistical tests that you use not always give you the whole information that you need to explain, right? So another approach, we call it as RAS model, it is giving you what we call as individual center statistic. With individual center statistic, then you can get information which student, for example, improve their ability individually, not as a group, right? Which items they tend to become understandable by the student, individual item, not the whole item, right? So this kind of situation actually give you more information, more data that you can analyze, that can explain better. In the context of journal publication, this is something that very rare that happening. People are busy with group center statistic, although the information provided not so much, not so big, not so comprehensive like individual center statistic, right? So the procedure in order to get the objective measurement, they are based on probability, right? So we are not emphasize on score only, we also look at the probability. For example, student A have a 9 correct answer out of 10. So from 9 out of 10 correct answer, we know that one item is not correct. So in terms of RAS, we are looking at the correct answer and also incorrect answer, right? So we have what we call odd ratio probability, okay? Because odd ratio not giving you equal interval scale, so we have to think what kind of mathematical function that can make that scale has equal distance and equal interval situation. So George Rush suggests using logarithma. Okay, when you are using logarithma, then you have an equal interval scale. You have the starting point, 0 in the middle. You have a linear scale, and you have also a unit, which is logit. Okay, if you go back when we talk about instrument in physics, so meaning that using approach in RAS model provide you the same quality like using instrument in physics. Meaning that you want to measure something hidden, something latent, but using this approach, using this model, giving you a kind of precision and a kind of accuracy that you are looking for, right? So this is an example of the report, which is about right map. It's come from the name of Benjamin Drake Wright. Okay.
Itu kan dipangkas Bu. Jadi satu semester.
Okay. So let me continue, right? Okay. So right map are telling comprehensively regarding about person and also item. This is a typical, we call it as individual center statistic, because it inform regarding about individual student quality and then individual item difficulty. Okay, so it gives you much more better information, right? So regard to the instrument testing, so as you know, when you create an instrument, you have to make sure that the quality instrument is something that has a good thing, right? Kalau kita berbicara tentang pengujian instrumen, maka kita harus tahu bahwa instrumen yang kita gunakan memang berkualitas. Oke. Yang pertama dengan reliability is about variation, is about number of data. Reliabilitas itu tentang angka. Makin banyak angkanya, makin besar angkanya, makin bagus. So you don't have to be afraid when talking about reliability, okay? Because reliability, as long as you have bigger number of items, bigger number of respondents, then you have a better index, right? Okay, so that's reliability. The second one is about validity. Okay, so something that a bit strange to explain, but I have to tell you like this. Validity is about argumen. Validitas adalah tentang argumen. Sedangkan yang banyak kita pelajari, validitas itu tentang angka. Validitas adalah tentang argumen. Yang tentang angka itu adalah reliabilitas. Oke, kalau Anda mempunyai jumlah responden besar, maka dengan sendirinya nilai reliabilitasnya bagus. Tapi kalau validitas bukan tentang angka, validitas adalah tentang argumen. So you have to state what kind of argument you want to show. Then support with the index that appropriate. It could be about construct validity, which is about the quality of instrument can measure from range of ability. Okay, is it about rating scale? Is it about item difficulty, or it is about preciseness? So you have to make it clear, right? It is not only about you showing this, then end of story. It is not like that, right? So you have to be careful in terms crafting the argument, right? So I think that's all for me. So thank you very much for listening, and hopefully can share something useful for you. So I wrote the 2 books regarding RAS model. So if you are interested to read, so you can contact the distributor, which is located in Bandung. All right, so thank you very much for listening. So I go back to Madam Moderator. Okay, thank you.
Thank you very much, Mr. Bambang Sumintono, PhD, for giving such informative and interesting presentation. Ladies and gentlemen, now we come to the question and answer session. If anyone to ask to Mr. Bambang, you can write them down in the chat room, or you can click raise button. Okay.
And you can ask in Bahasa Indonesia.
Yes, absolutely. Thank you.
One.
Actually, there is no question from the chat group. Okay.
Assalamualaikum.
Okay, Mr. Bambang Sumintono. Oh, yes. Who is speaking?
Sahal. Oh, okay.
Okay. Sahal Fawais. Okay. You can ask directly to Mr. Bambang.
Okay, thank you for your time. Assalamualaikum, Mr. Bambang.
Waalaikumsalam.
Actually, I have bought your book, and I have learned it. And from your book, I learned, and you suggest to use application for RAS model is forget.
You mean mini step and win step?
Yes, mini step. Yeah. But this application is limited for big data, and I try to search any application, and I found Excalibur and our software. And when I use it for our software and Excalibur free version, I got a different result. So maybe my question is for pemula, for like me, what your application can suggest for me? Thank you.
Okay, so can I answer directly?
Yeah.
Yes, please.
Okay. Okay. Thank you. Thank you, Mas Sahal, for the question. Right. So, what I can suggest in the book is just use the free version of WinStep. We call it as mini step. All right. Because this is free version, so actually is limited number of data that can be processed. Okay. Jumlah data yang bisa diprosesnya sedikit, yaitu 25 soal dengan 75 orang. Okay. So actually, compared to the other software, so WinStep, it is much what we call as cheaper than other, right? So WinStep, if buy a license, so it's around 2 juta rupiah, okay, for single license 2 juta rupiah. Kalau Anda bisa mengumpulkan sampai 30 orang, maka 30 orang itu cukup membayar sebanyak 8 juta rupiah. Jadi 8 juta rupiah bisa ditanggung 30 orang. Okay, so it is much cheaper. Okay, and this is lifetime. Ini sifatnya seumur hidup. Okay, tentu tidak bisa diwariskan ya ke anak ataupun ke cucu. Selama Anda hidup masih tetap bisa digunakan. Okay. Jadi itu adalah platform yang saya gunakan. Kenapa saya menggunakan MiniStep, WinStep? Karena semua atribut psikometrik daripada person dan item itu lengkap diberikan. Oke. Lalu juga ukuran filenya kecil sehingga tidak membebani memori laptop. Oke. Kalau Anda menggunakan R memang gratis, tetapi modul yang Anda gunakan itu sifatnya hanya mengeluarkan logit saja. Dia tidak bisa melakukan proses analisis lain, misalnya rating scale analisis, tidak bisa menggunakan diff analisis, tidak bisa misalnya melakukan analisis yang sifatnya multi rating dan selanjutnya. Jadi banyak keterbatasan. Oke, so saya tidak jualan software itu, cuman memang sepanjang yang saya alami pengalaman mencoba beberapa software, yang WinStep itu lebih banyak keuntungannya, oke, dan itu lebih manageable untuk digunakan, oke, baik untuk skala riset mahasiswa maupun pengelolaan perguruan tinggi. WinStep bisa mengolah data dari 10 juta responden, 10 juta peserta tes, dan 50.000 item soal. Artinya kapasitasnya luar biasa besar kalau mau digunakan. Right? So that's the reason why I use that, because it gives more information regarding about psychometric attributes, right? So if you have any question, just email me, right? Very happy to help, right?
Okay, thank you.
No worries.
Thank you, Mr. Bambang Sumintano, for your answer. There are some questions from
okay.
chat. First question is from Ibu Ima Roshida from UM. I want to ask about the reliability between
Alright,
traitors.
okay.
Yes,
Okay,
in
so
Haris. Okay.
Okay, so I just explain directly. Is it okay?
Okay.
Can I answer one by
Yes,
one?
please.
Okay, Bu Ima. So if we are talking about rater reliability, if you are using classical test theory, so you only can use Cohen-Kappa, Fleiss-Kappa, or G theory, right? So it is okay, but if somebody asks you a question, not just about reliability, which one of your rater are really consistent? Kalau pertanyaannya bukan hanya mengukur reliabilitas, pertanyaannya mana rater Anda yang konsisten, Anda tidak bisa menjawabnya. Oke? Mana item yang mempunyai kualitas lebih bagus, Anda juga tidak bisa menjawabnya. Karena Cohen-Kappa, Fleiss-Kappa, G theory, dia adalah termasuk kelompok yang namanya group center statistik. Dia hanya menghasilkan satu indeks yang menjelaskan semuanya. Sedangkan kalau Anda menggunakan multifaset Rush measurement, Anda bisa mendeteksi siapa juri atau rater yang ngelamun, mana juri yang konsisten, mana rater yang tidak adil, mana peserta tes yang susah dinilai. Artinya tidak akan ada dusta di antara kita. So all the data will be clear indicated about precise and accurate measurement. So my suggestion is try to use multi-rater analysis in RAS model, which is many facet RAS measurement. It will give you much better analysis, and of course, it can make you, the findings will be more suitable for journal publication, right? Why? Because in Indonesia at the moment, anywhere you go, when you are testing about rater, so most likely people are just stuck using Cohen kappa, Fleiss kappa, G theory, full stop. Okay, no other alternative available. So I mean, think about another alternative that can give you more comprehensive answer, right? I'm happy to help you if you want, right? So go to next question. Is it okay? I just ask, answer directly? Boleh?
Yes, yes, please.
All right. Okay. So this one is Bu Devi Fauzia. Okay. So what is validity about argument? All right. So the story. Okay. I explain in a simple thing. Okay. Kalau kita mengukur validitas, validitas itu bukan tunggal. Okay. Validitas itu adalah seperti spektrum. Okay. Aspek apa yang mau kita tunjukkan. Oke. Sekarang kita mempunyai instrumen, sorry ya saya pakai bahasa Indonesia ya. Misalnya saya mempunyai satu instrumen dan instrumen itu mengukur kemampuan matematika. Right? So, apa buktinya bahwa instrumen tersebut mempunyai kemampuan mengukur matematika? Right? So we are talking about construct validity. Construct validity, we are talking about the range of the ability of mathematics problem solving from somebody who are not able to solve to somebody who are very able to solve. Dari orang yang sangat lemah kepada mengukur pada orang yang sangat mampu. Itulah yang disebut dengan construct validity. Oke. Jadi konteksnya adalah argumentasi apakah instrumen tersebut mampu mengukur. Oke. Contoh yang lain, sekarang kalau kita membuat soal esai. Soal esai biasanya kita membuat rubrik. Biasanya katakanlah satu soal yang mudah, maka skor yang maksimalnya 3. Kalau soalnya susah, skor maksimalnya 5, misalnya seperti itu. Oke. Nah, pertanyaannya, argumen yang harus diberikan, apakah rubrik 3 atau 5 itu cukup untuk mengukur kemampuan siswa? Oke. Nah, sekarang lihat misalnya yang biasa terjadi di sekolah. Kadang-kadang guru membuat rubrik itu luar biasa, 1 sampai 50. Skor total 20. Nah, apakah ada penjelasan rubrik 1 seperti apa kemampuannya, 2 seperti apa, 3 seperti apa, sampai ke 20? Okay, so the argument is it the rating or is it the rubric really understandable by the rater? Okay, and is it the rubric reflecting the ability of the student to answer the question? So that's the argument. Right? It is not just only about number. Bukan masalah angka, karena angka dalam konteks tes kognitif selalunya bersifat data ordinal, bersifat label. Dia tidak menunjukkan pengukuran. Kalau kita berbicara pengukuran, maka kita berbicara pengukuran dalam fisika, yaitu apakah dia mempunyai titik nol yang jelas, mempunyai jarak yang sama, apakah dia mempunyai satuan, apakah dia bersifat linear. Sekarang hasil tes matematika, apa satuannya? Nggak ada kan? Maka itu tidak bisa disebut sebagai pengukuran. Right? Okay. Okay. I hopefully I answer your question. Right? So the next one. Dari Bu Julian Lani Utari. Alright, so the questions about measuring at individual level. So if you are using classical test theory, for example, you have two students, A and B, right? Both A and B correct 7 out of 10 question. Baik A dan B, dia betul 7 soal dari 10 soal yang diberikan. Bisakah kita memberikan informasi siapa yang paling mampu, A atau B? Dua-duanya betul-betul jawabannya sama, skornya sama. A betul 7, B betul 7. Siapa yang paling pintar di antara mereka berdua? So we are achieving limited situation when we are using classical test theory. Anda tidak bisa menjelaskan karena yang Anda jelaskan di sini hanya sebatas skor. Anda bisa mengatakan, oh bisa dilihat kepada tingkat kesulitan soal. Nah, tingkat kesulitan soal dalam konteks classical test theory, dia tidak menjelaskan soal sulit tersebut digunakan ke student yang mana. Right? So, for example, you have item difficulty level from 0 to 1. Right? 0 meaning very difficult, 1 meaning very easy. When you have an item with item difficulty 0.6, for example, to whom this 0.6 is difficult? Pada siswa yang mana nilai item difficulty 0,6 itu berhubungan? Anda tidak bisa mendapatkan informasi karena itu sifatnya group center statistik. Dengan RAS Anda bisa menjelaskan siswa yang mana yang tidak bisa mengerjakan soal dengan item difficulty 0,6. Alright, is it make sense? I think I already answered that one. Okay, so any other question?
Okay, thank you, Mr. Bambang Sumintono, PhD, for an interesting discussion today. Unfortunately, our time is limited. For participants who want to ask more about objective measurement to Mr. Bambang Sumintono, you can contact him on his email that you can see on the PowerPoint. Ladies and gentlemen, we finally come to the end of the last plenary session of ICoMSE 2020. Before I close this session, I would like to take the conclusion from what the speaker have presented. So, RAS model, by RAS model, we can get more information individually, not group center statistic, and it can be explained better, accurately. We would like to say thank you again to Mr. Bambang Sumintono, PhD, for his informative and interesting talk, and to audience for your active participation. Hopefully, the presentation will be beneficial for everyone. Good afternoon. Wassalamualaikum warahmatullahi wabarakatuh. And I will pass the time back to our MC, Ms. Rivka. Thank you.
Thank you very much, Ms. Latifa. Distinguished guests, ladies and gentlemen, now we will close the conference. I would like to now call upon Dr. Sumari as the head of Chemistry Department to present us with a closing speech for our last day of the 4th ICoMSE 2020. Dr. Sumari, the time is yours.
Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam.
Distinguished speakers of ICoMSE 2020, ladies and gentlemen, a very good afternoon, I bid to all. Let me begin by praising Allah Subhanahu wa Ta'ala and thanking all the committees, particularly Dr. Habibin, for your stewardship of our conference and the excellent organizer that you have just provided. I am very pleased to be with you, all of you here today, to officiate the closing ceremony of the 4th International Conference on Mathematics and Science Education 2020. Held virtually in 2 days by Faculty of Mathematics and Natural Sciences, Universitas Negeri Malang, Indonesia. It is fantastic to see that this conference has successfully attracted more than 300 delegates, ranging from the presenter, expert, and participant in the field of mathematics and science education from Indonesia region and countries from all over the world. At the opening session, the Dean said that he opened, we would learn new ideas from each other, which we could adopt to further improve our work in the area of mathematics and science education studies. I know that there have been many interesting and usable presentations in these past 2 days, both plenary session and the parallel session, which we will have it one more session this afternoon. I believe many good experiences have been shared and excellent lessons learned. Many people have commented that a lot of good work has been done in practicing education amid the disruptive era, especially nowadays. We are facing the pandemic COVID-19, and the presentation demonstrated good practical learned activities and experience. The change in focus from just the high level of proportional to the broader and profound educational discourse, especially considering the challenges of 21st century learning and life skill is to be welcome. The increased focus of STEM education, well-being in education, and transformative learning are also an appropriate development. Ladies and gentlemen, my heartfelt thank you and utmost gratitude to our keynote speaker today, Associate Professor David Gillan from Griffith University, Australia, Dr. Chun Yang Chang from National Taiwan Normal University, Taiwan, and Bambang Suminto, PhD from University of Malaya, Malaysia. And I would like to say congratulations to the 4th ICoMSE committees for this fruitful conference since its establishment. The success of the conference is the result of commitment of our partners and also the attendees of ICoMSE 2020. For speakers, presenters, and participants, I do hope that ICoMSE 2020 has left a memorable impression in your memories of the last 2 days. I wish a pleasant day to all and hope that you will visit Malang soon after pandemic is over. See you later on the 5th ICoMSE 2021. On the note, I now declare the 4th International Conference of Mathematics and Science Education 2020 officially closed. Thank you very much. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Thank you very much, Dr. Sumari, for the closing remarks. Ladies and gentlemen, this is the end of the plenary sessions of the 4th International Conference of Mathematics and Science Educations 2020. Let us all be guided by all the things we have learned and heard throughout the conference and be able to see the influence in our future. Thank you for all for making time in your busy schedules to join us here this morning. It has been our pleasure to host this event. We will have 1 hour break and we will come back to the parallel sessions of the conference at the other room. Thank you very much. I wish you all a pleasant day. Good afternoon. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.